All right. Today we're going to look at some soldering. So we've got a few things. I'm going to give you an example. Not going to solder the entire board, but show you an example of how to solder, and then tell you what you need to do to get your SD card shield working. So we're going to use a card like now. I have some switches and resistors and other things on here that you're not going to install yet. Mainly, we need these headers installed so that you can plug this into your Arduino. So it's a shield, and there's a lot of different types of shields. This one's called a SD card shield from SparkFun, and it will sit there and, well, not sit there, you actually plug it in. Plug it into your board, and notice that you can stack multiple of these on top of one another. We only need the one. And this will give us a SD card that we can use to store data for longer periods of time, or maybe we want to just take data and then put it on an SD card so that we can bring it into Excel, or we're going to use Python a lot of the time. But we need, in order to do this, to install these headers. And so I'm going to show you just a little bit of installing one on this shield. This is just a proto shield. It doesn't have anything on it at all. It's just a blank shield. So we'll do that later on. We're going to talk about how you deal with parsing through. So taking a file and separating all the little pieces of it into individual pieces again versus one long string of data. How you do that if it's an Excel file. A way that you can do that if it's just a comma separated file, or comma separated type of data. And I'll talk a little bit about SPI, serial peripheral interface, just mainly just to mention it and show you a little bit about what it does. Let's jump into coding first. Bring up Thani. So I've got Thani over here. Again, if you're not using Thani, that's okay. There will be a few, actually maybe in this one there won't be anything different. In the next one we do, there might be a few things that are slightly different, but they're not major. So what we want to do here is we want to find a big giant set of data. And so we're going to find one that's already created, but it could be that you get data off of an SD card that you've collected yourself, and we'll do that later. But first, let's just operate with a giant set of data that we don't have to go and try and find or get our equipment running to collect. So I'm trying to move it over here. Let's see if I can get it to where it's kind of on the screen. There we go. This is sportsreference.com. They have all kinds of data sets related to sports. This particular one I'm looking at is the 2019, so last year, college football final standings, final things. They've got some strength of schedule things, but what we're looking at is points per game. So it's got offensive points per game average that these teams scored, and defensive points per game average that these teams allowed against them. And it's for 130 of the FBS teams, I suppose. And we're going to go in and collect all this data into a file, and then we're going to use Python and Thani to sort it out, do a little simple calculation. Basically what we're going to calculate is, all right, so we know, actually it's not sorted by rank right now, it's sorted by conference and then rank within the conference, I think, maybe. So it's a weird, shows Louisville as number 2. That's not actually number 2 overall. So what we're going to do is we want to find, well, what team actually had the best differential between the points they scored and points they allowed. So what team has the largest margin? And, it might be Clemson. They've got a really large margin. They scored almost 44 points a game and only allowed not even 14 points a game. So that's a pretty large, but it is at the largest margin. And so that's what we want to do. So we want to go through this set of data. This particular set, it probably wouldn't be that difficult to just do manually with 130 data points, but you have to imagine if you've been collecting data on some device and you've collected hundreds of thousands of data points, it starts to get to where you can't do that manually. You couldn't go in and just look through it and find what you want. So we're going to use a data set that is large, but not, not incomprehensibly large. We can look at it all right here, and we could probably go in relatively quickly and find the one thing we're looking after. So what we want to do is, well, we've got this data set. Now this one might be a little bit difficult to follow along with, just because there are a lot of little steps that we have to deal with. But the first thing that we have to do is we have to get this data from this page over to our computer so that Python can interface with it. And I do want it to be a CSV, so that's the one that is comma separated file. So I want all this data every time I get a new data point, like when I move from this one for the AP pre-poll to the AP highest ranking that they achieved, I want a comma between those data points, because I'm not going to have all these little cells. I'm going to have a long string of data, and I want each individual data point to be separated by commas. That's the CSV, comma separated values. So the comma is called a delimiter. Sometimes you have tab delimited, so there's a tab between all of them. Sometimes there's space delimited, so there's a space between each data point. Sometimes those will get difficult because there might be text that has space in it, like Wake Forest has a space between the Wake and Forest, and that would mess up a space delimited file. So you'd have to figure out how to deal with that. So we want comma separated. So to get that, if I go to this and just hover over share and more right here, it actually it has Get Excel Workbook. It says it's experimental. We're not going to go that route. That might help. I didn't try that one. We're just going to get the table as a CSV, and then it says for Excel. But it's going to give us a generic type of file that has commas between all the data points. So we're just going to click that, and it basically turns the file, and now you can see all those commas, right? Actually, it starts out with 3 commas, so there must be 3 empty spots to start with. There's a bunch of commas in a row, all of this. So it just changed that table into a comma separated file. So we're literally going to go in here and highlight all of this, starting with those 3 commas. We do need to preserve those because they have to do with the spacing of everything. And then we're going to get all of these. So we will Control C or right click and copy, whichever. And then we need to put that into something like Notepad. So I'm going to get Notepad open. I'm actually going to use Notepad++. It's off the screen. Oh no, it's kind of on the screen. I'm going to use that one. Actually, I've already put it in there. Let's start from the beginning. All right, file new. All right, we just Control V or right click and paste, whichever. And there's all of that data in this file now. Now, I want to save this. Oh, let's see it. Yeah, I can probably, because it does, when you go to sportsreference.com, it does give you a lot of things to choose from. So this particular page I linked in the chat over here on YouTube, and it is, you know, it's the 2019 standings, but that link should go to this particular set of data. All right. I didn't think about that people might actually want to follow along with it, but there it is in the chat. All right, so I've got all of this data. Now, it's not actually a file that Python can deal with yet because it's just over here in Notepad. So I'm just going to use Notepad. It doesn't matter if you're using Notepad++ or just regular Notepad. It does kind of matter that you're using something like Notepad, because other programs, maybe Word, some of those, sometimes when you put a file like this into one of those and then save it, if you don't do things exactly right, you'll end up with some metadata. So like who wrote the file and what time was it saved, what time was it last edited, things like that, embedded in the file. And we don't want any of that. So Notepad, I'm pretty sure, is not going to put any of that metadata into the file. So I'm going to just do File. I'm going to do Save As. And by default, Notepad's going to want to save it as TXT. And I don't want that. I want it to have that CSV extension, .csv. So I'm going to type in, let's see, college football, school. It doesn't really matter what the name you use here is, except that this name matches what you have in your Python code. So whatever you put here needs to be the same thing that we put in the Python code when we go to read the file in. and I've put the CSV extension on here. And I need to save this. So one thing that's going to be important once we start trying to parse through this file is that this file and the Python code that we write to go along with it, they need to be in the same folder. I don't want to set up any path type issues where I can have to try and find the file somewhere. I don't want to deal with that. I just want to put them in the same folder. So I'm just going to put them on the desktop, actually. That's probably the simplest thing. All right, so college football, school standings 2019. I do have to make sure I use that file name when I go to open it. So save. And it already exists because I already did it once, but we'll replace it. Yours obviously won't say that. All right, that's all we need Notepad for. We can close that down. I don't think we're going to need that again, so we can just close that. We don't need that. We don't really need to go back to this web page either. So I think we're good with all of those. All right, so here we're over in Python. We need a new file, a blank file. And the first thing that we should do is we need to open up that file we just created. So I'm going to use F, doesn't matter what your variable name is, but F for file, but whatever you want to call it. And it's going to equal this command, open. And then we need to open that file that we just created, college football, school standings. And then I put 2019 in there. Dot, we need the extension on there, .csv. And close that. And not only do we want to open it, but we want to read it. So we'll read all of the file, put everything into this variable called F. So everything that was in the file that we just created through Notepad is going to be in this variable called F. We need to save this, and again, we need to save this in the same folder. So I'm going to put football, and I'm going to put that on the desktop so that the football Python program and the college or CFB school standings 2019 CSV file, same folder. And for me, I just put them on the desktop. All right, let's just run this and make sure we don't get any errors. It won't do anything, but we just want to make sure there's no errors. All right, so no errors popped up, so we didn't mistype something. We could have typed, maybe we spelled it wrong, and then we would notice that, hey, something doesn't work, and that's telling us that it can't find that file. So we have to go in and correct the spelling, and at least it doesn't do anything, but we don't get any errors. All right, so let's let it do something now. We opened the file, we read the file in, stored it into this variable F. Let's print F and see what it looks like. Now, we don't want to print the entire thing, so I want to limit just a portion of F. So to do that, I'm going to put a range in here. So I want it to print from 0. I don't need to put the 0, but I guess I could. But from 0 to 300. So this will give me 300 pieces of data in the file that is now named F, and it'll print those out. So I'm going to run this, make sure, and there they are. So so far it looks like we're working. Look, that does look like the things that I saw over here. You know, comma, 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 overall, all that stuff that shows up over here. So looks like it read it incorrectly. We don't actually need this line. It's just for troubleshooting, so we can comment it out. I just put a hashtag in front of it to comment it out. And now let's this file that we have down here, we want to start to get down to individual pieces of data. So let's look at this thing back as the how do I get back to the, what if we just go back, or reload it. Maybe if we reload it, there we go, back to this table. I want to look at things as individual cells again. So I need to divide the data into rows, and I need to divide the data into individual data points in that each row. Now it does have, if you notice, it does have the data already in rows. It's still in one big file named F, but it's separated in rows. And how they've separated the rows are with a carriage return, so like hitting enter on your keyboard. So I can use that to create all the rows. So rows is just a variable. You could call it whatever you want. I'm going to take the file that has all the data F, and first of all, I want to strip off any blank spaces. So maybe I went in when I copied this thing. Let's go back over to here. Maybe I highlighted too much, and I got this part up here that has these blank data points in it, so I didn't actually get some data. I got extra stuff. I want to get rid of any of that might be at the beginning or end of the file. So I'm going to strip off any blank spaces. So that's what that part does. And then I want to split the file F, or the data F, by rows. And I want to use that carriage return. Now, you couldn't just go in here and split. Inside the parentheses, I tell it what I want to split by. So I'm going to use this symbol. Well, it's not a symbol, it's a slash mark. So that symbol /n is the carriage return. That's how you specify end of line carriage return. So like hitting enter on the keyboard. So everywhere this line breaks to a new line, that can be encoded with this symbol /n. All right. So that should create rows. Now, the data won't look any different because it looks like it's already in rows. What it does is that it will let me address rows individually. So I could pick out a particular row and print whatever row I want. So let's do rows, and let's print the third row. All right, and so there's the third row. It's number 2, Louisville, ACC. Let's go look, make sure that makes sense. So the deal is that I actually got this first row up here with the bunch of blank spaces, overall conference points per game, that header. So that's row 0 actually. Remember the indices start at 0. The first row, row 1, is ranked school, conference, win, lot, all that header. So 0, 1, row 2 is Clemson, and row 3 is Louisville. So it did come out and give me row 3. So it looks like it's still working correctly. Again, I don't need this. I can just comment that out. It was just there to troubleshoot to make sure we're doing it right. All right, so now I've got I can individually address any row in the data file now. So what I want to do now is take all those rows and put all the little data points in their own cell, like Excel does. Each one has its own little cell. So I'm going to do that with first I'm going to create an empty list. So all this does is it creates a list. It prepares one, but it doesn't put anything in it, and it calls it cells. So the good thing about lists are that you can add to them as much as you want to. So we did a little bit last time with the append function, and we're going to do that again this time. And we're going to do a new thing in Python that we haven't done before, and we're going to use the for statement. So maybe you've written some Arduino code or whatever, and you used for and next together. Python does for a little bit differently. So for is still the key command word, but you don't go and do a range from for I equals 1 to 10. You don't do that. You do for every row in rows. And again, row and rows here are just variable names. So it's more like for every element in whatever set I'm looking at is how you read it. So for every row in the variable rows, so I've got 130 something rows. I don't know how many. There's 130 teams, but some of them have, well, when we did the CSV, the top row just had this first row had this, and then I've got 130 rows. So I've got 130, but I started in counting at 0, and I've got a couple of extras. So for every one of those, I need to do something. And what I want to do, I do need to indent. So I hit tab to indent because it needs to know what all needs to happen in every one of these rows. I'm going to take the empty list cells and I'm going to append data to this empty list. So I'm going to add to the end is what append means. And I'm going to add this. And now we'll have to figure out what this actually means. But it uses that split command again. We need another parentheses. All right. So I'm going to, for every row, so I'm looking at every row again, it's a variable name. It doesn't really have to be row. It could be for X in Y is fine. But remember, it's for every element in this data set. So right now this data set has, the elements are all in rows because we split them in rows by this end of line character up here. And I'm going to now take every row and split it based on a comma, and take every element. Every time I get to a new comma, I take that element that it separates from the other elements and put it into cells. So cells is going to have all of the data split up into individual little cells separated by commas. So it might take you a while to sort out what is going on there, but maybe if we print this, let's print something and so you can see what it looks like. And it will look a little bit different than what, not a lot different, but there is a key difference here. So this is just going to print the cells, or well, what's in the cells currently. So I'm going to print up to, so from 0 to 2. But now the cells are still rows right at this point, the way I've printed them. All right, so I did something wrong. What did I do wrong? Let's see. Oh, all right, so the for statement, I need a colon after that to tell it that I've ended the for statement, and now I want to tell it what to do. I left that off. There we go. All right, so now we can see I've got all this little data points separated by the commas. Notice it's added all these quotation marks. And so let's look at the first part. So what I have in the first one here is actually a space or an empty spot, and that corresponds to, there's nothing on the other side of this comma. It's just an empty thing, then a comma, then an empty, then a comma, empty, comma, and then a overall. And I've got that here, empty, comma, empty, comma, empty, comma, overall is in the print quotation marks, and then a comma. So all the little data pieces are in these quotation marks. And you can also see there's brackets. So here's a beginning bracket, here is an ending bracket. So all of this is the first row. Now, the way my screen is printing right now, the first row actually overlaps to the second row of printing. But you can see the first row, there's the beginning of the second row here, and then there's the end of it. This bracket matches with this first one, saying that that's the entire data set that I printed. Just rows, the first two rows. All right. I can also, if I take this colon out, then I will just print the second row. So it'll look similar, except it'll only have the second one. So there's what's labeled as row 2. Not the first two rows, but row 2. I could print an individual element. So maybe I want row 2, element 1. Remember, oops, get that back up there. Row 2, which is this row with Clemson, element 1, element 0 would be the number 1 here. Element 1 should be Clemson. So let's print that. We should get Clemson out. And we do. All right, so everything's working. We can hide this print statement again, just as a, if we ever want to go back and check it, we can check it again. But that's just for troubleshooting. And it's really good to troubleshoot each step as you go, or at least don't wait too long before you troubleshoot something, because it's harder to track down your error if you wait until the very end to start checking things. All right, so notice when I printed the first two rows. Well, it was in here, but it was when I did the :2. This is what I got. Overall, all this doesn't have anything to do with the actual team names. That's row 0. Row 1 is rank, school, conference, win-loss, all this stuff. That is not useful. So I'm going to get rid of those two. So once I have a list, it's kind of like there's a stack of data all stacked on top of one another, and I want to remove the top two things. I want to remove the top row that is overall conference, and I want to remove the next one, which is rank, school, conference, win-loss, all that. So the command for removing data off the top of a stack is you pop it off. Actually, I need to tell it which data I want. So cells, and then I want to pop off the top one, but I want to do that twice. So this just removes whatever the top two, in this case, each line removes the top one. So cells.pop will remove this one, and then rank, school, conference becomes the top, and then I do it again and pop off the top one, which would remove this one. So those two lines aren't in this data set anymore. In the cells, there's still an F up here, and they're still in the CSV, and they're still in rows, but they're not in the cells list anymore. We can print the top row now of cells and see what's in there. So it should be the Clemson line. Uh-oh. Why did it not? Did I? Oh, you have to tell it which one. All right, I forgot. You got to put a 0 in there. Sorry. There we go. And now, Clemson, if we don't put a parameter inside how many to pop off the top, then it doesn't actually do that. So we wanted to pop the top row off, which is row index 0. So now row index 0 is Clemson. So we've gotten rid of the header stuff basically, and we can hide this so that we don't have to deal with it anymore. You could leave all those print commands open if you wanted to, but there's no point to really. All right, now I want to go in and I want to get the team names, right? So that's this element. And some of these, well, here's the average points scored, and this one is the average points allowed. So I need all of that data. So let's get the team names. Let's just call it team names. So again, I'm doing the same thing where I create an empty list. It's called team names, so I can append data into it. And then I'm going to create one points per game, spread, and create an empty list for that. So I could create 3 lists, right? I could create a names list, a points per game, and a defensive points per game, and then do the math. But what I'm going to do is the data in this PPGS, the spread, is going to have the math already done. So it's just going to get the difference in points scored and points allowed. All right. So we're going to do a very similar thing to this, where we took every element in the set rows. So every row in rows, I'm going to take for every cell in cells. And we'll remember to put our comma or colon in here this time. I'm going to take the team names, and I'm going to append. This one is cell. So the variable name, variable name that we created, well, that we're creating right here, I guess. There's cell. We want team name is this element here. So remember index 0, 1. So we want 1. So this will take and go through all of our cells and take individual pieces. So this first one will take the name and put it into team names. So we'll have a list of all the team names. And then we'll do points per game, spread, and we'll append to that. So add to the end of it. We have to do a special thing here. We can't just do math on these two numbers, 43.9 and 13.5. Notice they're in quotation marks for one thing. So they're actually strings right now. They're not numbers that we can do math with. So I need the number equivalent, which is going to, if I tell it that I want the float value for cell, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is cell 9. And I want to subtract, oh wait, that 9 needs to be in brackets, not, actually this one should be also, those shouldn't be parentheses. You use the index numbers need to be in brackets. Cell 9, so the float value of cell 9 minus the float value of cell, should be 10 because it's the next one. So we're taking cell 9, which is this one. We're going to subtract off this one. Some of them might be negative. I guess it's possible that the team on average allowed more points than they scored, so it could be negative. And so I'm going to just do all of that math to create the point spread and put it into this list. And now we'll have the team name in one list, and we'll have the point spread in another list. Okay, let's see. We could check to make sure we have print team names, and let's just pick some number, 32. And then let's print the points per game for that also, the spread. Oh. All right, so team name cell object is not subscriptable. So I've typed something in here that I, oh. So when I wrote this team names.append, remember I had these as parentheses, and these should be the parentheses. The brackets tell it that there's an index inside of there, and the parentheses are just telling, you know, separating out the thing. Actually, these blue parentheses right here are saying these are the parameters for the append function. And so you can't have an index as a parameter for the append function. You need this type of thing, and there's an index inside of there. I had them backwards. I had the brackets here and the parentheses here. They should have been the other way. All right, so Texas Christian, they did score more points. Now, I've got a whole bunch of decimals over here. We'll deal with that later. It did calculate 3.9. I suppose we could go and check that that actually is correct. So here they are, 20, where are they at? 30.3, 26.4 is 3.9. I don't know where the O2, you know, all that, I don't know exactly where that came from. Anyway, it did work. And we can, again, comment out these unless you want to leave them in there. All right. Now, we have all the stuff now, all the data that we need. We've got to figure out now among all of these points per game spread, offense minus defense, which one's the greatest. So we're going to go in, first we're going to guess. And we don't have a reason to guess any particular number, so why don't we guess the first one? Now in this case, it is a really good one. The first one was Clemson, so they had a really large point spread. But that's not the point of what we're guessing here. We're just guessing that, hey, maybe the very first one is the best one. So we're going to guess that the maximum value, max value is referring to the maximum difference between offensive points scored, defensive points allowed. And we're just going to start at the beginning and work our way through the list. Index of max. So we need to keep track of which one actually is the largest one. And so we need to keep track of the index as we go through all of our list. All right, so this part, let's actually get a little, there we go. Here we're going to use the for statement for I and points per game. So I have two different things I'm iterating through. I is going to be the index variable that I'm going to use so that I can put different indices in here as I find new maximum values. And PPG is we're going to sort through the points per game spread. So this one is different from the others. The others kind of make more sense here. Now that there's two things out front, it might seem a little bit weird, but basically I'm just keeping two things going at once. And I've got another little special command, enumerate. So enumerate is a Python command that what it does is it takes and associates an index, in this case what we're calling I, with a list. So every element in the list gets an index, and it's actually spelled out. There's always an index there, but we need to spell it out so that we can put it into this index of max list. So this would not be an obvious thing to do if you were just trying to code this and you never coded Python before. You would not probably know that you needed to do this. All right. So now we need an if statement, because we need to find out, hey, if the one we're currently looking at is larger than the one that we previously had as our greatest points difference, then we need to replace them. So if points per game, so this is the current one that we're looking at, is greater than what we have in our max value. So our max value starts as the points per game for 0, which was Clemson, which had like let's see, it had 43.9 minus 13.5. So whatever that difference is, let's see, so we can talk about it. 43.9 minus 13.5, 30.4. So if the current one that we're looking at, now the first one is Clemson, so it's not going to be greater, it's the same. But the next time it goes through this loop, it'll be Louisville with, well, a negative. So they've got a negative 0.3, clearly not larger than 30.4, so it doesn't get replaced. It'll keep going down the list until it finds anything that's larger than the difference between 43.9 minus 13.5. It'll go through all of these, and if it ever finds something larger, then it will replace that one as our max value, and it hasn't yet, I haven't coded it yet, but it will also record the index of that team so that we can refer to it later. All right, so if we find one that's larger than our current one, then the new max value is going to equal whatever we just read, whatever we just read out of our list. And the index of the new max value equals whatever I is currently on. So we're iterating here, I equals 0, 1, 2, 3, 4, and so forth until it gets to 130 or whatever. All right, so that only happens if we find one that's larger. Otherwise, we're just going to increase I. Remember, this I plus equals 1 is the same thing as writing I equals I plus 1. So it just increments I by 1. And that's all we need. That will go through. What it's going to do is it's going to find the largest value, and it will put the largest value in this list, and it will put the location of the largest value, so the team it's associated with, in this list. So let's print that out and see if we have found the right one. So print the max value. This will be the largest point spread. Print, well, let's go ahead and print the index of max. So this will be just the number 0 to 130 that are 0 to 129, I guess, of the location of the maximum value. And then let's print the team name. So print team names, and we want to print the team names associated with index of max. Got all my parentheses and brackets correct this time. All right, so we run that, and I did something wrong. Oh, look at that. See, normally it tells you, kind of gives you a clue what you did wrong. It even tells you what line you're on. And so here, index max 0. I meant to write equals 0. All right. Oh, there we go. So the largest point spread, 33.2. Clemson had 30.4. So this is larger, so that makes sense. Its index is 36, so that's the 36th team in our list. And apparently that's Ohio State. Also good football team. In fact, let's see, they're down, where are they? Right here. 46.9 is their points average. Minus 13.7 is 33.2. And that's what it told us it was going to be, 33.2. So it looks like we found the right one. Now, obviously, this took us, what? Where's our timer over here? Like 30 or 40 minutes to do. But we did sit and like do every little explanation. We could have probably written this code. The actual code is it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 lines of code. So it's not that much code. Some of it's very specific code, like knowing to use the enumerate thing. The nice thing about this, though, is that this base code is pretty generic. You know, all we have to do is we could now go to any year of this data set, assuming they're all formatted the same, because we do have a couple of things hard-coded in. Like over here, we're assuming that the cell number index 1, so the second thing in our row, is the team name. So if they ever change that, then that wouldn't work. 9 and 10 represent the offensive and defensive points. So there are some things that are hard-coded in that we would have to assume that this website didn't create different types of tables from year to year. But we should be able to take any of these, change it to 2018 or 20, whatever they go back. I don't know how far they go back. I don't know. I assume we could find that if we wanted to. And do the same thing without changing anything other than the file. So this is more an example of how you do this versus maybe the best way. There are a couple of other things you can do to get the same type of data. But this probably is the clearest, even though there are a couple of things like enumerate in here that you wouldn't necessarily know about. And probably the for structure is different from another language that if you've coded in any other language, the for next, well, there is no next, but what you might call a for next statement looks different in Python than it does in other languages. All right, let's take a break from coding and let's look at our soldering for a little bit, and then we'll come back and do some more coding. All right, let's get the calculator out of the way. Now, I've got just a blank, let's take it out of here. Just a blank board that you could put some kind of chip over here, you know, IC, maybe a surface mount thing over here if you wanted to. You're going to have one that's got a SD card. There is a surface mount chip or a little reset button. None of this stuff in the middle. You just have holes in yours. And you're going to need to put some headers in here so that it can plug into the Arduino. So I've done one just to kind of show you here. When you have these cards, I'm touching all over it. So everywhere you touch like this, it's going to get a little bit greasy. When you're soldering, cleanliness is your main goal. Dirt and grease and grime make it hard to solder, harder than it needs to be to solder. So it wouldn't hurt to, maybe we'll solder this board in, or this header in over here. It would not hurt. We're actually going to solder on the back side to go in and clean those off. And look at that. There's now, if you rub too much, you'll actually rub, see how they're shiny? They actually have some solder already plated onto here. Now, if you got too aggressive, you could actually, like if you took sandpaper or something. So it's just a Q-tip, and you can just clean off the oxidation. And there's still a little bit. All right, and so I'm going to solder in there. Now, this particular board has 2 rows. Now, your board does also have 2 rows, and 2 rows side by side. And you don't want to put the leads through the wrong set of holes, because then what you have to do is unsolder everything, which is a pain, because these are going to need to line up with the ones on the Arduino. And it's the outside row, for this board anyway, it's the outside rows line up with the headers that are already on your Arduino. Also notice there's this little bump right here. that corresponds to this little bump on the Arduino, so you can kind of orient which way it's expected that it's going to go on there. If you did it the other way somehow, I don't know, maybe like this, flipped it over, you would have some problems because some of these pins are expected to connect to certain pins on your Arduino to operate the SD card. So make sure you do get things lined up according to this little bump. So don't do it upside down. I think it's pretty obvious which side is the top, but maybe it's not. They're pretty similar, you know, when you're just looking at a blank board. Now, on yours, you'll have the SD card reader in there, so that's the top. So it's probably more obvious which is the top and bottom of the SD card. All right, so I'm actually going to work on the bottom because I want the solder on the bottom. You do not have to have one of these little things. You can put this on, you know, a table or whatever. In fact, putting it on a table might actually help because it'll hold the header from falling out. So we just need to get this guy in here. And now there are a lot of different positions here, right? So you want it to be pretty much perpendicular to your board. If you get them all splayed out in different directions, they're not going to plug in to the headers they need to plug into, not easily anyway, and you're going to have to bend everything. So try to get everything straight the first time. See if I can get some more on here to hold it up. Maybe we can put this one over here. I'm not actually going to solder this over here. I'm just using it as a stand so it sits level. If I can get it to go in there. Oh, one of those is kind of the wrong size for these leads. Something on here is going to match. Well, maybe I can just put it on this side. There we go. That helps sit level. So you don't want these sitting out sideways or anything like that. You want them as straight as you can. So maybe we won't use that right now. I have some flux, no clean flux paste. You don't absolutely have to have flux, but it does help. And you don't need a lot, but the idea with flux is that it helps the solder flow onto the spot that it's supposed to flow to. All of this red on here is a solder mask, and solder won't naturally stick to the red part. So sometimes you have green, you know, like a green circuit board. Doesn't matter. The color doesn't matter. Sometimes they're black. But the fact that it keeps solder from sticking to any place other than these plated spots does help avoid like a solder bridge where you actually end up connecting two of these together by solder. And the flux helps everything flow a little bit smoother. I will put some flux on here. Let's see if we can get closer. I think I do want to use this just so I can keep it at an angle and maybe you can see a little better. So when you're just doing it on your own, you don't need that. You want to hold it up like that. I may, since I'm going to spread that lead out just a little bit so that it, let's see if we can, there we go. Focus on that. All right. So I just spread that one out a little bit. Maybe I'll spread this other one a little bit just to keep it from falling out on me. Because I don't want a big gap over here. I'll have to try and hold it while I'm doing that. We'll deal with that in a minute. All right. So I'm going to put a little bit of solder in here. This solder always squirts out a lot at the beginning. That's plenty. You don't need more than that. You probably don't need that much, but got that in there. I've got relatively thin. Now this actually is a rosin core solder here. So that means it has flux inside the solder. I'm gonna just keep it as clean as I can. Also got my soldering out. Now if you go to grab your soldering iron and it's all black up here, there's a really good chance that it's not going to solder very well. If a big mistake a lot of times is going in And I'm going to turn this on, so now hopefully I don't grab the thing in the wrong spot. But a big mistake is trying to use too much temperature. You know, you just crank the thing. Mine goes up to 850 degrees. You don't need anywhere near that to solder. This stuff melts at like 350 degrees, maybe 400. I've got it set to 425 right now. So that should be plenty hot enough to melt it. I'm gonna, once it starts to melt over here, let's see if I can get, there we go. I'm gonna kind of clean it off a little bit. It's not quite melted yet. Let it heat up. You can kind of see over there how it's nice and shiny. You want shiny. But this stuff oxidizes so fast. I also have one of these that we can clean it up with a little bit. All right, and let's tin this. So that means put some solder on here. There we go. There we go. So now I've got melted solder on, and there's a little bit of smoke coming out there. Got melted solder on the tip. Got flux over here. It's going to be awkward for me to try and get to, but we'll see if I can do it. And the idea is I want to heat up the pin and one of these little pads at the base here so that they're both heated up. And it doesn't take terribly long, you know, 3 seconds or so. And then I want to introduce the solder and have it flow into there. I'm a little bit off the screen. Let me see if I can. The camera is really in the way of where I want to solder. It looks like we got a big giant blob in there. I don't want big giant blobs though. Let's see if I can get to it at a better angle this way. Still think I'm getting not quite flowing, so I'm not heating up both things quite evenly. That might be. I can actually see better. Yeah, so see how there's a little cone right there? You don't really want a big ball of solder on here. Usually if you have a big ball of solder on there, then you have probably created what's called a cold joint. And it's kind of just hovering above the pad. It may mechanically hold it in place, but it's not actually doing anything electronically. And sometimes that's all you want. There are some elements that you just want mechanical fixture. But the good thing about these little boards is that's kind of all you really need is mechanical fixturing, because the pin is going to go down into the socket on the other one. So the only reason that you would actually need an electrical connection here is if you want to take advantage of these other rows here. So the little rows on the inside, sometimes maybe you want to solder something to that, put a resistor, like a pull-up resistor or something in front of one of these or whatever, I don't know. So you actually don't need, for this shield, anything other than the mechanical fixturing, but might as well practice it and get some good soldered joints. So the idea is that you are heating up the pin and the pad, and you are going to get the solder to flow in there. The better it flows, the better you have created a soldered joint. So you do all of that, and again, for you, it will probably be that all you need, any amount of type of solder will work to get them attached. All right, then you want to clean off your soldering iron, maybe re-tin it so you can put it away, because who knows when it's going to be when you use it again. And then put it up. All right, and you do that over and over and over again until you've got all these lined up. Now you can check and see if you've got not only electrical connection, but your mechanical connection. Now I only did, well, I did 3 of them, didn't I? Did 3, so they're in there good. I still don't have the fuse, hasn't come in for my other multimeter, so we're still on this guy. And we just want to check for continuity. This one has a really, there it goes. And if I have electrical connection between this pin and the board, then I should be able to have continuity between here. Oh, let's see if I can find a way that you can see these. Yeah, so all of these little holes, like this hole and this hole, they're connected. There's a little tiny, you probably can't pick it up, but there's a little tiny bridge between the two in the circuit board. So I should be able to detect that connection if I touch the pin and the hole. See? So that means I did actually get electrical connection between there, not just mechanical. Same thing there. And same thing there. You might even have it on these. See, but this one I didn't solder, and I can wiggle it around and get it, but it's not actually there. So a lot of times, those are the if you're needing to use these inner pin, anywhere, which I don't think we're going to use them. Let me see. I didn't use them on the other one. So that's when you run into trouble, where you've got a big ball of solder on here, and it looks like it's holding it in place, but it's kind of wiggly, and you're not actually getting any electrical connection between them. But sometimes it does. Maybe you've got it bent in just the right direction and it does make contact. That's frustrating to try and figure out, because sometimes it works, sometimes it doesn't. Most of the things that we will do won't matter for the course. It just might matter later on if you need to ever use this inner row of holes in here, or on here. So what you're looking for, not too hot. You don't want to burn up the soldering iron tip. You don't want, or you don't need any more than maybe 400-ish, 420, maybe 450 degrees on your soldering iron. You don't want a big giant piece of solder for smaller stuff like this. They do make different size tips. I think this one's probably a good size for this type of work. It's not one of the super tiny ones. They do make some that are like little points. Do I have one like this? Much smaller. You might think that, hey, it's smaller and I can get in here. It is made for smaller work, but for this size that you're trying to heat up here, the mass that you have, that like you can generate a more heat, not necessarily temperature, but more heat by having more mass here, and get that heat to flow into this larger pin and into the pad that it's needing to connect to. If you were trying to, maybe if you were trying to solder something here, smaller leads, smaller pads, then a smaller tip does make sense. But in general, I like this size. It's not gigantic, but it gets enough heat into normal size stuff that we're going to use better than some of the smaller pieces. All right, so you need, again, you probably will not do this wrong just because of the nature of how we're going to use this. We're just going to plug this in. So these pins will be plugged into these sockets, and you will certainly get a connection there. There are a couple of connections that you do need to make sure are done well, because some of them take this connection and bring it over to the SD card. And if you have a bad solder joint on that, and it's kind of the big blob of solder, or maybe you did a solder bridge. A solder bridge would be where you have two big giant blobs of solder and they're touching each other, and so it connects two pins together. That's going to create problems too. So do try to get these nice small little cones of solder at the base. They should be really shiny. Mine are shiny-ish. I'm not a like expert solderer, so they should be really shiny. A lot of that has to do with keeping the tip clean, keeping your solder clean, using flux if you have it. I didn't point this out. I told you, but I didn't actually say anything about it. This is the no clean flux. Some flux you do have to clean off of there. Actually, all flux you probably want to clean off just because it's going to get sticky over time if you don't. But there are some that you don't have to clean as far as it's okay. It doesn't make electrical connections. But some solder flux does need to be cleaned up later, or you'll have electrical problems. We do have some soldering irons set up in the lab. If you don't have your own, you can go to campus and use one there. All right, let's go back to some coding, but not for too long. Let's say that this time we want to use an Excel file. So we didn't quite use an Excel file before. We used a CSV that could have been read by Excel, but it wasn't actually read by Excel. Let's see if I can find my pages of stuff. Actually, before we get into that, let's talk about the serial peripheral interface really quickly, just because that's kind of what we're working on over here. So serial peripheral interface, SPI, that is a way that you can connect one electronic device to another one. So usually it's like a microcontroller, the Arduino, to a sensor, the ping sensor, or whatever sensor you're trying to connect to. And I don't know when SPI was created. It's new compared to other ways of communicating between electronic devices. I don't know an actual date on it, but let's just call it new. And what it does is the difference is, and if you could read this if you wanted to, but the difference is that old serial communication relied on both things, the microcontroller and the sensor, or whatever they are. Maybe it's a printer or whatever. It relies on them basically communicating at the same rate. So they both talk at the same speed, and they both listen at the same speed. And so there's some syncing that has to happen where maybe the sensor has some data it needs to relay, and it sends out a signal that, hey, I'm about to send some data, here it is, and the receiver, the microcontroller, the Arduino, is listening at the correct rate. So, and the rate is called baud. Maybe you've seen that before, but let's just use a really simple number and say that the receiver is listening at 100 baud, so 100 bits per second. That's really low, but let's just use it for a simple number. So it's listening at 100 bits per second, and the sensor has to send data at 100 bits per second, and it has to, some of that data that it sends has to be information saying that, hey, I'm about to send data. Hey, I'm done sending data. You know, it has to take up some of the time to actually tell it to start receiving and stop receiving data. So these markers on the end of the data. So it takes more data. It does require that they're always communicating the same rate. If the receiver was listening at 100 bits per second, expecting data to come that often, and the sender is sending out 50 bits per second, it's going to be confused. It's going to not collect the data correctly. Or maybe it's sending out 200 bits per second, and you're listening at 100, you're going to miss some of the data. And so there's a lot of synchronizing that has to happen. So that was old, or well, that still happens, but that's not SPI. So SPI, same type of thing has to happen where there's communication. They do have to communicate at the same rate, but they don't have to be programmed ahead of time to have that set up. So the clock, so this S clock is the serial clock. The clock is generated by whatever is called the master over here. So maybe the Arduino usually the microcontroller is going to generate the clock. And this slave over here is going to be the sensor, whatever sensor it is. And so that clock signal, the timing of when data is going to be expected to be received or sent, is generated over on the Arduino, and that serial clock information is sent to the receiver, the slave, not the receiver necessarily, but the sensor, and it will send out data based on that clock that it's getting. So it's kind of like this. Let's see, there's probably, this picture doesn't, or these don't have a little symbol of clock. The clock is basically just a series of on and off signals that are oscillating at whatever frequency you want to send this data. There are a couple of other lines here. So MOSI and MISO, they sound like words, but they're actually acronyms for master, master out and master out, slave in, master in, slave out. That's what they are. Oh, there they are right there. So I knew they should be on this page somewhere. But so this is and notice the direction of the arrows here. If the master, the orangish one, needs to send some kind of data information, not normally data, but some kind of signal to the slave, so the sensor, then it has a line for sending data out. There's a line for the slave to send data, usually data, over to the master. So that's what we're going to usually be doing, is we're going to send data we've collected. Maybe we're measuring temperature, that temperature data goes over. And then there's a fourth line, SS, that's slave select. So you could have a lot of different sensors all running from the same Arduino. So maybe you've got a temperature sensor, an accelerometer, and a humidity sensor, and they're all running this SPI interface. They can all share the same clock. They can even share the same MOSI and MISO lines, so the master can talk to each one of them individually, and they can each send information back, so data, temperature data, tilt data, and humidity data. They can all send them back to this one line on the master, and then the slave select is used to tell the sensors which one is being talked to. So the others are silent while I'm talking to the temperature one. And so that select switch is going to select which one you want to talk to. So that's just an overview of how this SPI stuff is going to work. And the good part about it, there's two main good parts. One of them is that the clock is generated by the master, so you don't have to have all of these operating at the same, they don't have to be set up to where they're all the same frequency. The clock is going to be generated by the master, and it's going to tell them when to send data. And the other thing is you can have many sensors connected to one thing. They can share that clock, they can share the data lines, and they do have to have an individually addressable or way that they can be turned on and off. That's the slave select. All right, so enough of that. Let's code some more. Let's see, this time we are going to use Excel. So here I've got, let's see if I can find the link for it. I'm going to put this link in case y'all want to see it. This is from some MIT election data. So it is over here, election lab, mit.edu/data. And they have Senate data, presidential data, House, county, presidential election return. They have a lot of different data sets. We're going to write a little Python code that's going to use a new library. So we'll have to install a library. Probably, I assume you don't have it already installed. But this little library is going to let us use Excel files, and a little bit simpler than what we did the previous one where we had to parse out all the data ourselves. You might imagine that this is something that people do relatively often, so somebody out there has written a library to do that, and they have. And it is pandas. Let's get Thani up. So there's two libraries, well, one library and one kind of accessory library, I guess. So tools, manage packages, pandas. I have the most recent one installed on here, but you probably don't. If you don't, then you need to put click install. powerful data structures for data analysis, all that kind of stuff. It has some statistics built into it and all that kind of things. But it lets us work with Excel files directly. So you want that. Pandas relies, well, it tells you down here. Well, it doesn't say the one that we want right here. But in order to operate or integrate with the Excel files that we're going to use, we also need XLRD. Let me see if I can get the right name here. XLRD, yes. Find that one. I already have the current version of that one also. But XLRD, you would need that also. If you don't have that one, you might end up with some errors when you try to import pandas and run some of the commands because pandas assumes that you actually have this installed also, and you probably don't. So you need those two. I already have them. Let's make a new one. We got to get our data, I guess. So let's go back to here. We're going to use the presidential election data set from 1976 to 2016. So that's all of the presidential elections that we've had since 1976 anyway. What we're going to do is we're going to parse through this data using the pandas library, and we're going to find the person who won your state's election the day or the year closest to when you were born. So, not every year is an election year. So I want to get this data. Let's see which one I want. I think it's the by state one. Let me make sure though. Yeah, this one. All right, and so I've got two options down here that I can download. None of them actually say they are Excel files. One of them says .tab, and the other one says .md. We are going to download the 1976 to 2016 President tab file. Download. Now, there is a comma separated value version of this one also. We could go and do that same process we did, but we want the tab delimited. So this is the same type of data, except now instead of commas between everything, there are tabs between everything. So we're going to get the tab delimited file. It downloaded down here for me. It didn't ask me where to save it, but it saved it where in my downloads folder, I guess. All right, so you get that. Actually, I've already downloaded it before, so it appended a 1 to the end of it. Again, same thing where you want this file and the Python that you're going to run in the same folder. So I just put them on the desktop. All right, I think that's all we need from the data. So we have the data set. All right, so we are using the library this time, so we're not going to have to write everything from scratch. This one might be a little simpler. So import pandas as PD. Again, you don't have to do the as PD part. All that lets you do is it lets you, instead of writing pandas every time you want to use a pandas command, you can write PD. So let's run this. Actually, let's save it on the desktop. I already have a president. Let's call it president 1. All right. Run. All right. And again, it's not going to do anything. That just tells me that I actually do have the pandas library installed and running. All right. Now, if you're using Thani, which I am, then all the output's going to happen down in this window at the bottom, and Pandas is expecting a bigger screen, basically. So what I want to do is set some options. So PD is Pandas again. Oops, I got to spell option though. Option. And then I want to set the display max columns. Display max columns. Got to spell it right. To 999. So that will, if I don't do this, what will happen? Well, we'll turn it off and I'll show you. But we don't have anything to show yet. Set option. Display width. and I'm going to set that at 1,000. Oh, left the quotation mark. The color coding helps track down some errors. All right, so we'll turn these off once I have some data to show, so you can show what they're doing. Now, birth year. Now, this data set goes back to 1976. If you're like me and born before 1976, then just use 1976. But most of you, I assume, were not born before 76, so put your year in here. And then birth state, whatever state you were born in. Now, this does have to be spelled so that it matches up with the states in the list, so it's not the abbreviation or anything. We have to spell the state the way that you actually, I don't need that parentheses there, actually spelled in the list that it's searching for. All right, so you will have potentially different, certainly I would assume different birth year, but maybe different birth states also. All right, so all we did there is basically we put in some information about us that will be used as search terms later. All right, so df, this is a variable. We use df. It doesn't matter what you use here, but these are called data frames, is how Panda talks about the sets of data. So df makes it sense for a data frame. Data frame equals, we're going to use the pandas command, so pd, and we're going to read an Excel type of file. Now I do need to go get this file as Excel. Right now I have it as a tab file, so we can't do this yet, but let's finish writing out the name. And then whatever we're going to call this thing, president data, we'll call it that. And XLSX, so I'm going to save it as that type of file. Right now I don't have it saved that way. And I need to close the quotation mark. And I need to say what sheet. Now it only has one sheet in it, but it's 1976. I'll show you this once we open it up. All right, so I've got an extra parentheses from somewhere. I think that's okay. All right, so we need to create this file because we downloaded a file, but it was a tab file. So I need to get Excel open. Let's get it on the screen. We can just take, I don't know if it's off, it might be off the bottom of your screen right here, but I'm just going to drag the tab file that we had downloaded, and I'm going to drag it into Excel. So that's all I did. I just dragged the file itself on top of Excel. If you don't have that option, then maybe you have to do file open. Now it is a tab file, so it's not going to see it in your normal list of files because it's normally looking for Excel files. But here's the data. And it's thousands of lines long. I don't even know. 3,000 lines long. And here's that sheet, 1976, 2016 president. So that's the sheet name that we put in right here. So those have to match. And then we need to save this file as this name on the desktop, or at least wherever you save this Python code. So file, save as. By default, it's going to put it as txt, but I want XLSX, so that's the newer Excel format. There's also there's several XLS. It's the older Excel if you're working with older Excel files. That should also work with pandas, but this is the one we're going to use. And we named it president data. Yeah, we named it president.data over there, so we need to name it the same thing over here. President data, and it should add the XLSX, and I want to put that on the desktop though. Okay, so that should have this file on the desktop. So back in Thani, if we run this, we should get no errors basically. Let's find out. Oh, I got a whole bunch of errors. All right. Oh, I got a configuration option on this. Oh, because I spelled it wrong. Look, I didn't put the A in there. Try again. All right, so that's what it does. Nothing. It just doesn't give us any errors. So it's always good to write a little bit of code, test that out, see if you can track down the error. Here it was just we left an A out of display. And we didn't get any errors on this line, which means that it did find this sheet, it did find this data file, and it put all of the data into this data frame that we call DF. All right, so let's print out the data frame. So here is a pandas command called head, which is just going to print out the top 5 rows of this set of data. Now, actually, normally you could use df.head, but in Thani you actually have to do print df.head to make it actually print it out. All right. And there, down here, oh wow, it's scrolling all over. These are the first 5, the header, or you could have tail, df.tail, and it does the bottom 5. You can put a number in here and it does a certain number of the top or bottom. And here are the rows. Now, if I don't have these options, let's turn off the max columns option and run it again. And see how it puts these little, it tries to fit it all into a smaller area, and a lot of your data is just kind of missing. It just does ellipses to show that, hey, there's stuff there, but I'm not going to show it to you. So you probably want to see that. Same thing for the display width. If I don't have the display width to 1000, then it's going to chop it off in little segments, which actually might be easier to read. But you know, it kind of shows this little symbol right here showing that it's chopped off at whatever number of columns it decided to use by default. And that's not bad. But if you put the 1000 in there, then it will overrun the screen unless you make the font really small. So you could go in here, and I think Control minus makes the font small, but that might make it hard for you to see on the screen. So I will increase that back. All right. And so it does wrap around. But that's what the 2 option commands. Those really probably only need to be done if you're in Thani. All right. All right. Let's not print this. Let's comment that out. All right. So now we can use some of the pandas commands to sort through this. Actually, first we need to figure out what your election year was, because you probably, you may not have been born on a election year. So to figure out what election year was closest to you, or well, the one right before when you were born, or the one you were born on, it's going to equal your birth year. Got to spell them all correctly. Birth year minus your birth year mod 4. So remember, mod 4 is going to divide your birth year by 4 and then take the remainder. So it's going to just subtract off any years where you weren't born on an election year. Presidential elections are every 4 years, and it will, I spelled birth wrong again, and it will figure out the one that was close to you. All right. Let's print that out. Maybe we'll leave this one in. Print election year. Now for me, I had to put 1976. 1976 was an election year, so it should just print. There it is, 1976. Yours will print whatever election year was close to you. Close to or before you, I think, is the way it'll work, because we're subtracting off this remainder. All right. Let's see. We need 2 conditions. So condition 1, we need to find the year, the election year, and then we need to find the state. So we have 2 conditions. So condition 1 is going to be look through the data frame, and we want to find the year column, and we want, notice this year is not random. There is a year label, and this is one of the things that pandas does, is it'll take the label from an Excel file and use those for you to sort through. So you don't have to do column 1 or column 2. You can actually use the column heading, assuming that that first row of data is column heading information. If that's not true, then it won't work that way. So data frame year equals, now Python and a lot of computer languages are like this, where when you're doing an assignment, like up here, birth year equals 1976, I want to assign the value 1976 into birth year, then I use a single equal sign. If I am using a comparison, I type 2 equal signs, and this is really easy to forget that you need 2 equal signs for a comparison, like in an if statement, or in 1 equal sign for an assignment. I want to assign a value to a variable. So if the data frame year column equals election year, so for me 1976, condition 2 is going to equal the data frame. Look in the column for state, and we have one called state somewhere right there, and we want to find our birth state. Oh, I don't think it likes it when there's capital letters and we have them in lowercase. I'm not certain on that, but I think it would matter. All right. So now we have our 2 conditions set up. So we're looking for the year that matches our birth year and the state that matches our birth state, whatever's in these variables that we created up here. Well, actually election year was created right here. Okay, now we've got those conditions. So the results, this is just a variable name, equal our data frame with condition 1 and you can do ORs and things like that. So you can do different Boolean operations here to combine and exclude different data points. So basically, our results are going to be all the ones that contain 1976 and Louisiana. And we could add, I think it can, I don't know if there's a limit on how many conditions you can do with pandas. I've never actually ran into it, but there might be some limit somewhere. So let's print these results. All right, so we should get, let's not print that election year. We don't need that anymore. All right, so we should get all of the 1976 Louisiana lines. And there they are. All right, so these are all of the candidates that were running for president in 1976 on the ballot in Louisiana. And now what I want to do is I want to find out who actually won Louisiana. So we're going to sort them. So a variable, we'll call it data, doesn't matter what you call it. Looking through the results, so just the ones that are 1976 Louisiana, and we want to sort them. And actually, I think they're already sorted by votes, but no, they're not. Yeah, they are. They're already sorted by votes. But just in case they weren't, we're going to sort the values, and we want to sort them based on the column called candidate votes. There's no space in the column header, so we can't put a space here. And we could sort them ascending or descending. We're going to do ascending. And, oh no, we're actually going to do descending because we want the larger ones top. So we'll actually turn this off. So ascending is false. We will print, remember the head command that we used up here. Normally the head will print the top 5 if you leave it empty. We only want the top 2, so the winner and the runner-up. So we'll do a 2 in here. Okay, so now we've created a variable called data, and it has just the top 2 vote getters for Louisiana. So it should be these 2, Ford and Carter. So let's print that and see if we get Ford and Carter. All right, we did. We got Jimmy Carter, Gerald Ford. We got their lines. All right, so that's working. Let's comment those out now. We're just using those to troubleshoot. Now it's as simple as the winner. This is just a variable or winner name. Oh wow, something happened there. We got a little lag. Is data, so that's the file we just created with the 2 top vote getters, equals iloc, or no, dot iloc. Iloc is a index location for pandas, and we want the name is going to be 0, so it's referring to the top row. So we have them ascending, so the winner is the one at the top. So the top row, and the value in, where'd my mouse go? The candidate column. So the nice thing about using pandas is you don't have to refer to things by index position. You can refer to them by the column name. That's one of the more powerful things about it. There are other features also. This has been much simpler, I think, than what we did in Python earlier. So let's get the rest of these. Let's get the party. It is the same setup. We want the winner, so that's the top one, and they have it labeled as party. That's simple. Let's get the number of votes they got. And again, this 0 here is that we want the winner, so that's the top row. And then the votes is total votes. No, that's total votes in Louisiana. Candidate votes. Okay, and then let's, oh, it doesn't matter, but I did spell a weird winder. So it's a variable name, so it actually would be okay, but let's spell it the right way. Let's get the runner-up's number of votes. So the difference here will be when we go to reference the row, we want row 1, so we want actually the second row. And same thing though, candidate votes. So this will be the number of votes that the runner-up got. So how many Gerald Ford got. All right, let's do something different here on how to display stuff. So we haven't done this a lot, but let's create a little paragraph of how to display. So we're going to print, and we're going to do a combination of text in the, and then we want we're going to concatenate, so plus, we want to add 2 things together, but not numerically. The string version of election year, because remember, it's actually I haven't mentioned this. So by default, right here, birth year and birth state, I didn't have to tell Python that this was a number and this was a string. A lot of times in Arduino and other languages, you have to initially tell a variable what type of variable it is. Is it an integer, a float, a string, or whatever? Python doesn't do that. It doesn't typecast variables. So it figures out what you want them to be based on the context most of the time. Sometimes it helps to enforce that. So, hey, election year is a number, 1976 for me, but I want the string version of that because I want to print it. So I don't want to literally add the number 1976 to the word in the. So it would try to figure out how to add those numerically. So that's why I've put string in front of here, so that it adds it as a string. Strings are just characters you see, not numbers you can calculate with. All right, so I'm going to add so right now I've got in the 1976 is what will show up. US, well, let's capitalize it. Presidential election. Let's see, what have we got? I don't want to put that. I want to run to a new line here. Oh, I didn't close my print quotes there. There we go. Always good to figure out what you did wrong. End equals, oh, it's just, I think Python doesn't care if you use double or single quotes, but I'm going to use single. Print. So now I've got in the 1976 U.S. presidential election, end line. We're going to go to the next line. The presidential candidate, and then we're going to put in our winner name. This one I don't need to tell it is a string because it's already a word. It's you know, Jimmy Carter, or Carter, comma Jimmy. If we wanted to sort that out, that would be a little bit more. We'd have to go split those Carter, comma Jimmy by the comma, and then rearrange them into Jimmy Carter, but we're not going to worry with that right now. So we're just going to have it Carter, comma Jimmy. We're going to add in that we're going to put in a parentheses. We're going to tell what party he is, but we're going to put that on another line. Close that one. Whoops, not or. Print a new line. We have an open parentheses. Let's put winner party. That was the line 26 up here. So now it'll say the Democrat or whatever's in that. Let's see. Yeah, it'll say Democrat. All right, so we have winner party plus in quotation or in parentheses 1 by. Now we can do some math. All right, so it's not going to match double quotes to single quotes though. There we go. 1 by, and now we can. Let's see. We want the string version because we want to print it out, but we do want to do some math here. So winner vote minus what do we call it? Runner vote. Runner-up vote is what we're talking about. So it doesn't convert. It does this math first, and then it converts that to a string so it can be printed to the screen. So it'll just do the math of subtracting the number of votes Jimmy Carter got, which is this 66,000, from the number of votes that Gerald Ford got, 58,000, and then it'll print that difference in there. So then we're going to add just a space, just to space it out. We'll end the line and then print the last line. So it 1 by this subtraction votes with, and then we'll print how many votes he actually did receive. I need to end the quotes. This gets difficult. I've already got it written down. It's not difficult to do. It's difficult to keep track of when you need a space and a comma and whatever. So this is certainly one that you would need to spend some time sorting through. Which do I need right now? The color coding does help though. Plus total vote. So all the green stuff is going to just be stuff I typed. All the other stuff is stuff that the data is being pulled from the database or the data frame. In, and then we'll put, let's close that and then put, so it should say Louisiana there. And we will add a period to end the line. I think that's all of it. Let's test. Oh no, we got something wrong. We have an invalid syntax with winner vote on what line? 33. So in our very last line, votes with string winner vote, which we do have winner vote defined, and we actually used winner vote up there, plus total votes in birth state. That looks okay. Well, let's comment that one out and let's see if the others are working. Oh wow! All right, so look at that. it couldn't find that because it's spelled wrong. All right, so now it printed this. I wonder if it'll work on this one now that I corrected my spelling. No, it still doesn't like this. Oh, because I don't have an operator between these two, so I need to tell it to add that together. There we go. In 1976, we need a space after 1970s. In the 1976, we need a space right here. All right, in that, the presidential candidate Carter, Jimmy, which again, we could sort that out. He's a Democrat, won by that calculation. Is that... Oh, and then there really should be a space there. All right. So it makes it look, you know, very nice in the end, but you have a lot of formatting to get to something that looks like a sentence you would write or whatever. And even then, there's a little bit of weirdness with the, you know, last name, first name, comma thing. But you can do, and again, this one, we actually had the results right here. So we didn't do nearly as much coding. We did it faster. And the pandas is probably going to be, unless you're specifically told to use something other than pandas, probably going to be the easiest way to deal with data that we're going to collect from something like our SD card. So some things you need to work on are soldering up your SD card reader. There's a SparkFun, a link to it on how to actually solder these in. There's no trick to it, but you should be able to solder the 4 headers together so that you can plug this shield into your Arduino. There's a couple of codes that you can use to test that you're able to read and write to that SD card. And then we can move forward with actually collecting some data, putting it on the SD card, and then taking it off of the SD card like an Excel file. And then we can do things like what we just did here with, once it's an Excel file, assuming we formatted it correctly, then we have a lot more things that we can do. We can do some plotting. We haven't really done a lot of that. The very first lecture we did some Python plotting, but we can do sorting and plotting and calculations and analyzing and filtering and all kind of stuff. You probably won't need the board soldered right away. Let me see if I put a date on there. I think next week. Remember, we're not on Zoom or anything or YouTube Thursday, so we won't be meeting. So you have all of that day, and probably it's going to be good to get it done for next week, because on next Tuesday what we're doing is we're doing some temperature measuring, and you're going to use the SD card to record some of that temperature. So we won't do it on Tuesday, but I will on Tuesday, and then you guys will spend the next week working on the thermistor recording data to your SD card starting on the 29th. So it'll be, you probably have a week or so to get the thing soldered up. And it only takes, 10 or 15 minutes to actually do the soldering that we need to do. So it's not terribly long. All right. Check out Moodle for more details on, I've linked plenty of things. Oh, and there is a little quiz. It is on a podcast. So it talks about how you can fool yourself with data. That podcast is linked over in Moodle, and you can check that out and go in and listen. It's 13 minutes long, so you listen to it, take the quiz, and that's all there is to it. The quiz is linked in Moodle, but it's not a Moodle quiz. It's actually a Google Forms quiz, I think. So make sure that you're using your LaTeX email address. All right. I will see you guys later. I'll hang around in office hours if you have questions or whatever. And then we'll be back, not Thursday, but Tuesday.